Hello from my home to yours. My name is Alex McVittie, and I am a 2018 Space Apps winner, and currently I'm employed at Skywatch, which was formed out of winning the 2014 Space Apps Challenge. Today, I'm very excited to show you how to work and download Earth observation data, and throughout the duration of the weekend, I'll be available virtually to assist your team with any issues that you may come up with. So, without further ado, let's get started.
So, the first question you might ask is, what is Earth observation, or EO for short, data? Earth observation data is commonly referred to as satellite data, but more specifically, satellites that observe and record data of the Earth. Since there are also communication and GPS satellites, those are producing satellite data, just not Earth observation data. There are many types of EO satellite data, but the main type we will be focusing on today in this tutorial is the simplest to understand, which is multispectral optical satellite data. Now, there are other types of Earth observation data, such as radar data and hyperspectral, but we will not be exploring those today. If you would like to inquire further about those types of data, you can feel free to drop me a line via email. So, what does multispectral mean? Multispectral data simply means that the satellite is capturing data at multiple points of the electromagnetic spectrum, which you may remember from elementary school. So your standard phone camera captures images at 3 points of the electromagnetic spectrum, which is within the visible light portion of it, at the red frequency, the green frequency, and the blue frequency. When you combine these together, you get a color, or RGB, red, green, blue, image. Now, multispectral satellites capture at these frequencies, but also collect outside the visible light spectrum so that scientists can do more analysis on the data observed. So when it comes to Earth observation data and doing analysis, you do have to keep in mind some very important things. What is the scale of the area that you are trying to measure? How often do you need data captures of it? And how much am I willing to spend? So the first thing you need to think of is spatial resolution. Spatial resolution refers to how much stuff can fit into a single pixel. For instance, if you have a data set with a resolution of 30 meters, this means that one pixel, the very smallest thing, if you zoom into an image, it's what's called pixelated. You can see all the little squares. Each of those little squares in the image will cover 30 meters by 30 meters. So, by federal law, commercial satellite imagery is restricted to a resolution no finer than 35 centimeters. So, measuring anything finer than that would require you to fly a drone or plane to capture the imagery. Now, the larger your area is, the lower the spatial resolution of your input data needs to be. For instance, if you're measuring the change in area in a large forest due to forest fires, this would require a much lower resolution than, for instance, counting cars in a parking lot. For the use case of counting cars, you would want under 1 meter resolution to count the cars, while if you're measuring change in, say, the Amazon rainforest, this would be doable with either 15 or 30 meter resolution data. Now, you could do the analysis on the Amazon rainforest with much finer resolution data. This would just require much more computing power and storage, since even jumping down from 30 meters to 15 meters resolution, while you're doubling the resolution, this houses 4 times the number of pixels. And if you really go down to a 30 centimeter resolution image, that has 100 times the number of pixels as a 30 meter resolution image. So generally, on larger scale things, you're going to want to pick the lowest possible resolution to process. The other thing you need to consider is, how often do I need this area revisited? A satellite is often part of actually a constellation of the same satellites. So you actually have, when you say Landsat, there's actually generally a few satellites that are orbiting, and they're all capturing at the same level of data quality. So when you have more satellites in the constellation, this means that, well, the constellation is just going to be collecting more areas more often. For instance, some commercial vendors, like Planet Labs, offer daily revisit rates with some of their constellations. Today, we are going to be doing some basic Earth observation analysis using some low-resolution open data. So we're going to be performing what's called NDVI, or Normalized Differential Vegetation Index, today to assess the vegetation cover and water presence of an area around an urban and rural area. So what NDVI is basically a calculation between a red band and a near infrared band, and we're going to be using open data to do this. We'll be using Sentinel 2 data. So the two prerequisites we need before heading on to the next portion of this tutorial is to have QGIS installed on your machine, as well as to have a Sentinel Copernicus access login as well. Both these are free and are readily available to download and set up. I'll have links in the description so that you can easily get that set up. So just pause the video now and get it all set up, and once you have everything ready to go, feel free to continue the video. Okay, so once you have QGIS open, there are a few steps that we need to do first before we can continue. The first thing we need to do is we need to install a few plugins. So the two plugins that we're going to need to do, they're accessible through the plugin menu at the top. You're going to go Plugins, and it's right there, Manage and Install Plugins. So the first thing we want to do is we're going to search for Quick Map Services. That's accessible. You just search Quick Map, and it should filter out to that. So since I already have it installed, I don't have the option to click Install again, but you'll have it right where it says Reinstall Plugin. It should say Install Plugin. So you're going to click that, and it'll install. And then the next thing you need to do is then, just like I searched for Quick Map, we're going to search for what's called the Semi-Automatic Classification Plugin, which is a mouthful, so I'll be referring to it as SCP, and you can even find it that way. Searching for SCP. It's not the first one, it's the second one, the semi-automatic, the big mouthful. So what you're going to do is select that, and just like how I already have it installed, and you don't, you're going to click Install here. It'll say Install Plugin. So you click that, it'll install, and then this big menu bar should appear on your install of QGIS. So the next thing you're going to do is we're going to add a base map using that Quick Map Services plugin that you just installed. So you're going to go Web, Quick Map Services. Now I already have this contrib pack installed, so your list of base maps is not going to be as large as mine, but we're going to fix that in a second. So you go all the way down here to Settings, and you go to More Services, and you're going to click this Get Contributed Pack. So you're going to click that. It's going to tell you that it's being downloaded and installed, and then you're going to click Save. Now, when we go back to Web, Quick Map Services, you can then choose from any of these options. Personally, I like using the Google Satellite option as a base map, but feel free to have a look at all the other offerings that this plugin offers. So we're going to click Google Satellite, and now you have a pretty familiar looking base map. So what we want to do is we want to zoom into an urban area of your choice. So I'm from an area in southern Ontario in Canada, and right here, and it's called right at the region of Waterloo. So it's right here. So we just want to have an area that we know has some urban. It's really good if you can find an area with urban and water. That generally gives you the best results for NDVI. So you can see a stark contrast between the urban area, the water area, and any kinds of fields, crops, you name it. So this sort of a study area gives you the best results. But you can really choose any area. It'll still work. So the next thing we want to do is we want to navigate to the SCP plugin, and we're going to click this button right here at the far left. So we're going to click that, and what we want to do is we want to enter our login data. So you're going to enter in your login for your Sentinel hub. You're going to type in your username and your password and hit remember, and then we're going to do search. So what we're going to do is we need to set the area on the map. So we're going to click this little plus button, and what we want to do is you want to select the lower right. Now this is a little frustrating thing about the plugin, because when you select the lower right, it's actually going to fill in the upper left. So we select here. So what you need to do is you just need to copy this upper left coordinate section into the lower right. So you just move this value here to the third. You move the first text box to the third, and the second text box to the fourth. And then you're going to do the exact same thing again, but you're going to click here, and you're going to click the upper left section of your map. So now if everything went okay, you should see this sort of translucent orangish polygon appear. So the next thing we want to do is we want to select Sentinel 2 from the source list. And in this case, it doesn't really matter what date, because we just want to see the NDVI, but you can set your date range of when the images were captured. So I'm just going to leave this as stock from 2016 all the way to 2020. The biggest thing we want to set, though, here is the max cloud cover percentage. Because we're working with an optical satellite, if there is a cloud in the way, we can't really do much analysis on anything under it. It's just going to show up there, and it can skew your values. So you want to set that to be pretty low so that we get non-cloudy images. And what we're going to do is we're going to hit this find button. And what that'll do is it's going to do a remote search and search the catalog of Sentinel-2 images that all the way from 2015 to present day. And it's going to check the date range. It's going to check the cloud cover percentage. And it's going to fetch them and bring them back in. It is a little bit slow. Windows, Mac OS, or Linux might tell you that QGIS has frozen. It has not. Don't force quit it. Just let it do its search, and it's gonna populate this table here in just a few moments. Great. So after a couple minutes, I was able to populate it. And so what you'll see here is you'll see this list because we only asked for 20 results tops. It's going to give you results from 1 to 20. So this is all these products do intersect our area, but they might not intersect them as well as other ones. So if we go here and we add this one to the map, we can... Seems to be not working. We can do so we can select this and we can add one of them to the map. And if we zoom in now, it does not seem to be it's just showing the footprint right now. So it's showing, so we can see here that this image here, it's going to cover up this area. Usually it would actually bring in the image, but for some reason, as with all demos, things don't work properly. Maybe this one will. There we go. So something was just up with that one product. So we can see here that this product here, it covers some urban areas. Hamilton, Ontario is right here, and there's some cities here and there. So this is going to be good. There's also it's on the Great Lakes too. So this is pretty much an ideal product to showcase NDVI. So what we want to do is we want to get rid of all the other products because we only want to download the one. So we're going to select all these and we're going to click the minus button. It's going to ask, do we want to remove the rows? Going to hit yes. Now it just takes a few moments to remove them. Because it has to download the thumbnails for some reason. But anyways, it'll run and remove all of the other search results. Great. And now we just remove the first two. Get rid of those. Yes, we want to get rid of those. Great. So now we have just this one. And be sure to uncheck only if preview in layers. I find that this doesn't work, so just leave that unchecked. We want to apply pre-processing, and the last thing we need to do is to go to download options. In here, in your case, all these bands will be checked. Now with Sentinel 2, with calculating NDVI, you need the red and the near infrared bands. In Sentinel 2, this is bands 4 and bands 8. So to save on download time, we can uncheck the rest of these bands, and it will only download the 2 bands that we need. So with that unchecked, we're going to go here, and afterwards we do want to load the products into QGIS. So we're going to hit run on this, and you're going to hit OK. We're going to download to this folder that I have here. And it takes up about 200-300 megabytes of space, so just be sure that wherever you're saving it, you do have that amount of space on your computer. And so you're going to hit open. And now we can see here that QGIS has begun downloading it. This is one of the bands, 104 megabytes. So we're gonna let that run. You can even step away from the computer at this point if the download is taking a while. It plays a loud chime-like sound at the end of the download. So that's just if you're away, it'll alert you. But if you're using headphones, I would recommend turning your volume down a little bit, as it is quite loud. So our product is now in QGIS. You can see here that it's a gray band image. It's not color like our preview is, but that's expected. We only told it to download the red and the near infrared bands, and that's exactly what it did. You can see here that they are each their own file, band 8 and band 4. This is what we want. And so the next step is we want to pull up our raster calculator. So under the raster menu, we have a thing called raster calculator. So we want to bring that up. And so I have a few other things because I was looking at some stuff beforehand. So we only care about this band 4 and band 8. So band 4 is our reds. So we want to take this and put it after our near infrared, like so. And NDVI is calculated as near infrared minus red. And then we need to put some brackets here. And then we need to divide that by the exact same expression. Well, not quite exact. We're going to copy it, but we're going to change that minus to a plus. And so it says the expression is valid. If it says it's invalid, make sure you didn't accidentally remove one of the quotation marks. Make sure that you have an opening and closing bracket. Just triple check your syntax. And then all we're going to do is we're going to save it out to a file. We're going to call this Southern Ontario NDVI.tif. So we're going to save that somewhere. It's a pretty small file, and we're going to hit OK on this. What this does is it's going to calculate it. And what we're left with is this grayscale image. Now grayscale is okay, but I mean the data is still there, but it doesn't really show us where the low and high NDVI is. So what we want to do is we want to right click on this and do what's something called layer symbology. So right down at the very bottom under at properties, I'm going to click on that. I'm going to change from single band gray to single band pseudo color. So band 1, I'm going to change this color ramp. You are probably going to have some like light blue to dark blue is what I found as the general default, but you're going to set this color ramp to red to green. It's the textbook standard for NDVI, and that's how they're all color ramps, this red, yellow, green. What that'll do is it's going to have the very lowest of the low values, so that's your open water. That's going to be as close to -1 as you can get, really. And then all the way up to forested areas, dense crops, etc. is going to be your green. Urban tends to be around the middle, and when we hit OK on this, that's exactly what we get. So we've got the Great Lakes is going to be this dark red colors, along with any water bodies. Like for instance here, let's just let's uncheck a couple of these layers here, so that when we uncheck the NDVI, we can see what we're looking at. So if we uncheck this, we can see here that yes, these are indeed water bodies. So NDVI is a great way of seeing where your water is and where crops are. For instance, here we've got some pretty dense forested areas. Looking around here, we can see right here we've got a river. Zoom in. There we go. That's your river because it's a very low NDVI. Uncheck. And you can even see like which fields were harvested. You know, you've got, for instance, this field here. You can tell that it's barren or was recently harvested compared to a field over here where it's still got crops, right? So there we go. Yeah, you've got a bare fields, but over here you've got a more populated field. And same here, we've got an urban area, so that shows up in our sort of around 0 values.
I hope that this new skill set will help you during this hackathon and beyond. There are a number of companies and industries that use EO data on a daily, weekly, or monthly basis to monitor assets from oil and gas to energy and utilities, forestry, mining, agriculture, and analytics. Knowing how to take advantage of EO data could be a very valuable skill in your career. Here at Skywatch, we make Earth observation data accessible for companies and developers. If in your future you need high-resolution satellite data for your application, come talk to us.